Welcome to this lectures. So today we will going to see this lecture electromagnetic spectrum, the part of atomic structures. So in this electromagnetic spectrum, what is the meaning of spectrum? Spectrum actually it is meaning is a form of appearance. This is the meaning of spectrum. So it is given by scientist that is called Newton. So he first described this spectrum. So we will see, already we have seen the electromagnetic radiations. In that we have studied that after the passing of the sunlight through the prism, we will see in spectrums having consist of 7 colors, that is called as waveguide. So that we have already discussed it. This waveguide is a spectrum. This is a spectrum which consists of this different colors of having different wavelength. Okay. So let us know some terms related to these things. So already some terms you might have studied in physics. These terms associated with the spectrums are, let us revise it. Dispersion. One term is called dispersion. What is dispersion? It is the splitting of a beam of light into radiations of different wavelength or frequency after passing through a prism or diffraction gratings. So we will take a prism. So here this light is going. So this prism will split. It will split this beam of light into different colors, and these radiations having different wavelength, different frequencies. So if this wavelength is coming under the range of visual, which is visible to the eye, so we can see this wavelength. This is called a dispersion. So this is the term called dispersions. Next term is spectrum. So spectrum is a term which is the pattern of radiations observed after the dispersion. So this is the pattern of radiation. Pattern means violet, indigo, blue. This is the pattern. This is decreasing order, increasing order, pattern of emission. Or you can say impression produced on the screen when radiations of particular wavelength or frequencies are analyzed through a prism. So these radiations are analyzed according to the decreasing or increasing of this particular wavelength of frequency. This is called a spectrum. And splitting the spectrum, this spectrum is produced on the splitting of the light, called dispersion. Another term is called electromagnetic spectra. So it is an electromagnetic radiations arranged in an increasing or decreasing order of either of properties like energy, wavelength or frequency. So these radiations, already we have seen the diagram, it is arranged according to the increasing or decreasing order of the this spectrum as per energy, wavelength or frequency. This can be energy, wavelength, frequency we have seen earlier also. It is an this spectrum is an array of waves or particles spreaded according to increasing or decreasing order. So this is the meaning of the electromagnetic spectra. One term is spectrograph. So this is an instrument. Basically, this is an instrument. It is used to separate radiations of different wavelength or frequencies. So we can say prism is an instrument. So prism is a spectrograph. So but this is the highly not qualified. This is a highly developed instrument, okay, device. And the photographic plate is used for recordings called as spectrogram. So this is the very developed instrument used in the laboratories. Now next is your monochromatic radiations. So radiations having only one wavelength of frequency is called as monochromatic radiations, and it may be obtained by filtering the ordinary radiations through slits. Through slits we are passing these radiations, and there are so many slits are there. So on these slits, after passing through the slits, this radiation has been filtered, and then we'll get only one wavelength. So basically we don't need to know too much things in details as per the topics our chemistry. So in chemistry we should not study this much. We know the terminology, because terminology is a requirement for the study. This one, monochromatic means single radiation having single wavelength, like this in spectrogram, all these terms that we have already seen. Depending upon the source of radiation, spectra are broadly classified as. Spectra means here we are dealing with the spectral lines. So spectral lines means like violet lines, like red lines. These are the actually spectral lines having characteristic wavelength. So these spectra are broadly classified as per the source of radiations. Whatever we are putting we are supplying radiations from the source. So it is a two type emission spectrum, and second is your absorption spectrum. So again, emission spectrum is different types, that is continuous spectrum, discontinuous spectrum, band spectrum. So we will see all these things in detail. spectral lines. Here I wrote some notes in the footnote. Spectral lines are highly atom specific, which is one specific, every line is specific to the atom. That's why it is called as highly atom specific, and used to identify the chemical composition of any medium capable of letting light pass through it. So each atom has a specific spectrum lines. So this is also used as a tool to identify the atoms. So once you know the spectrum lines of the atom, so if you seeing the colors of that atoms, you can identify which atom is present in that particular substances. For example, elements like helium, thallium, cerium, they were discovered by this spectral line. So characteristics, wavelength of the helium, thallium and cerium are quite distinct. So if the wavelength is matching with the characteristic atoms of this wavelength, so we can say that particular element is present in that substance. Like sun is made up of helium. So this we discovered only after the spectral lines. Nobody has gone to the sun because sun is very hot. So how one can go on? But with the help of this spectrum line, we can tell the constituents of elements present in that substance or any star. So this is used for describing those type of celestial bodies. So these lines are the actually result of interaction between atoms, molecules, nuclei or single photon. So this is the interaction. So this we have to not see in details, just we have to know only elementary knowledge. Let us see emission spectrum. What is emission spectrum? On basis of radiation, two types we have seen it: emission and absorption. Emission, what is this one? When white light emitted by a self-luminous object is dispersed by a prism to get the spectrum. So here one diagram is also there. The light is going through a prism. So this is split into this part. So this is a emission spectrum. So it is produced due to an atom or molecule making a transition from a higher energy state to a lower energy state. So when an atom is having a transition, means when electron is transferred from the higher to lower energy state, then this results the emission spectrum. So keep in mind, it only results when electron transfer from higher to lower energy state, not from the lower to higher. Lower to higher will be your absorption of energy, and this is the emission of energy. So this point is very, very important. Transition takes place from higher, then this spectrum can be produced. So energy of the emitted photon is equal to the energy difference between the two states. Two states mean the higher to lower states, and difference of that energy will give you particular wavelength. That wavelength is the is called emission. It produced in the spectrum is called emission spectrum. So there are many possible electronic transitions, and for each atom and each transition has a specific energy difference, obviously. So each transition must have the specific energy difference, and this collection of different transitions leading to different radiated wavelength make up an emission spectrum. So this is the meaning of emission spectrum. Let us see through different types how these different type of emission spectrums are there. So this is a diagram of continuous spectrum. We can see here. So this emission spectrum, one light is going through the prism. It is split into different colors. So it is resolved to several colors. Already I have written one here. So we can see these colors: violet, iodine, this is indigo, blue, green, yellow, OR. So this is the increasing wavelength, decreasing wavelength. Say ultraviolet. This we cannot see it. This is the source of light. So here source of light from the sun, filament or incandescent bulbs or flame of any. You can use the source of light. This is hot gas, or you can see hot gas. This light is coming. We will get continuous spectrum. So in this spectrum there is no sharp boundaries. We cannot distinguish between the sharp boundaries. Means one wavelength finished, then second wavelength start, then third wavelength start, that we have seen in the rainbow. That's why it is called as rainbow colors, continuous spectrum. So continuous spectrum, these wavelengths are continuous in nature. Now what is discontinuous spectrum? So discontinuous spectrum is the when gases or vapors of a chemical substance are heated in an electric arc or in a Bunsen burner, light is produced. So this is same thing is there. This is gas is there which is passed through a chemicals. It is vapors of a chemical substance are heated in electric arc, and when these lasers pass through a prism, then line spectrum is produced. Lines means see, these are the wavelength are produced. Remaining of these are the portions are the dark lines. These are the dark spaces they are dark spaces, and this is called as a discontinuous spectrum. So there is sharp boundary. You can observe this dark spaces are actually the sharp boundaries which were absent in the continuous spectrum. So these lines are distinct, and it will be always when same light is passed to the prisms, it will be always observed like this only. So this is the characteristics property of every element. That's why it is called as each line corresponds to a particular wavelength. That's called atomic spectrum, since it is produced by the atoms. And the pattern of lines of the element characteristics of is the characteristic of that element. So pattern of that lines of an element is characteristics of that element and is different from the spectra of all other elements. Sodium, lines of sodium will be different, lines of hydrogen will be different, lines of helium will be different. Means these lines are used as a fingerprint of the atoms of a particular element. So the line spent is fingerprint of the atoms of a particular element. Like fingerprint of the every human beings are different. So if lines are different, then we can identify these elements are also different, these atoms are also different. So this is used for identifying the atoms. So in this way, the sun, helium was identified from the sun. Sodium vapor produced two lines. One line see in the yellow region of spectrum. So one is your 59 angstrom and second is your 155596 angstrom, not 59, it is a 5896 angstrom. So these two are different angstroms. So these are produced. So this technique is helping discovery of some elements like rubidium, cesium. So these two elements were not two elements. There are so many elements discovered. So this technique is used to discover basically elements. So we have seen this V viewer is the continuous spectra, but if you miss some line like I is missing, G is missing, O is missing, so this becomes discontinuous spectra. So these spaces are actually the dark spaces that I have shown in this diagram. So here this discontinuous spectra is actually the missing wavelength. So discontinuous lines are not continuous, there is no sharp boundaries, but continuous they have sharp boundaries and the wavelength are continuous. Band spectrum, so it is a group of lines that are closely spaced and arranged in a regular sequence that appears to be band. So these here lines are closely spaced and arranged in a regular sequence that appears to be band. It is band like, and these bands are colored band, and these are separated by dark spaces on the two sides and arranged in a regular sequence. You can see, so these are the dark lines, okay, and these are the colored lines. So you can see here in this color line there are difference of some decreasing intensity like this, or decreasing, but this will be broad band. This is the little lesser intensity, this is more lesser intensity. So these type of lines are formed. So here again some lines are there, again some dark spaces, some lines are there, some dark spaces. So like these lines are there. So this is the colored band. So these are colored band, these are colored band, these are colored band, and closely spaced lines 1 2 3 4 1 2 3 1 2 3. So it is a color band separated by the dark spaces on the two sides and arranged in a, so this also in a regular sequence, and it consists of distinct dark bands. So all are distinct and produced by the excited source of in a molecular state. So hence called molecular spectrum. So these are normally produced by the molecules like hydrogen, H2 molecule, carbon monoxide, ammonia molecule. So these lines are produced in a band that's called as molecular spectra or band spectrum. Now reason. So what is the reason for the formation of this band spectrum? So it is a spectrum of polyatomic systems. Polyatomic system means atoms having polyatoms. Each line corresponds to one level in the atom and splits in the molecules. Since its bands consist of so many atoms, so many levels are, so many energies are there. So these energies may be produced from the different levels of the atoms. So as per the previous emission spectrum, we have seen continuous band is continuous wavelengths were there. So similarly here some wavelengths were there, but this is produced by the what happens, molecules. That is not produced by the atoms. So one level in the atom splits in the molecules. When the number of atoms is large, it gets a continuous energy levels and so-called spectrum lines. So here large atoms means large spectral lines, and these bands may overlap. Overlap means and their corresponding densities are added. Corresponding density means we are talking about intensities. So here bands may be overlap. So if there will be large spectrum lines, so maybe one spectral line will be mixed overlap with the second spectral lines. So there will be one band, the second band, then third band. So this happens with the molecules. when light of this molecule pass through the prism. Now next is absorption spectrum. So what is absorption spectrum? When white light is passed through a prism, a few dark lines or bands are obtained in the otherwise continuous spectrum. So this white light is passed through a prism. Here you can see this diagram. So here prism is there. In this prism, what happens? So this white light is passing. So here is a bulb, is an incandescent bulb. This passes a cold gas. This light is passing through a cold gas. This is the prism. On passing prism, a spectrum is obtained. This spectrum, if you see, we can see this thing. So these are the actually lines which we can visible, we can see it, and these are the dark lines are there. So why these dark lines? Like previously we have seen the broad dark lines, but here there are thin dark lines are there, and these are visible spectrums. This we can see it. So few dark lines or bands are obtained in the otherwise continuous spectrum, and these dark lines depends on the nature of the absorbing media. So this is called as, this type of spectrum is called as absorption spectrum. So like emission spectrums, it may be also continuous, it may be line, or it may be band spectrum. So we are not going all these things in detail. We are not going to see all these things details. So here I have given one examples to understand. So this is the continuous spectrum in which we have seen Vi, B, Y, OR, and again in continuous spectrums we can see one dark line, one dark line, one dark line. This dark lines means no light, no spectrum is there. We can see violet, we can see blue, we can see orange. So this has been absorbed by the medium. So this is obtained. So this is what we call absorption spectrum. So in this topic we have to know the elementary knowledge. There is no much numericals are there, but this is very important for the practical point of view, so that we if want to study, that we will study in higher classes.